All right, I think we left off on F. We skipped to F. Right? We were looking at two possibilities that would create domain restrictions. Right. The first one was we can't have a 0 in the denominator. Right. So no zeros in the denominator. And in practice, what that meant was set the denominator equal to 0 and solve. Okay, those will give us the values that we cannot have. Okay, our domain restrictions. Then we started doing an example of the second one. Okay, the second one was we can't have negatives under a radical. And in practice, what that means is take whatever's under the radical and create an inequality. Say that has to be greater than or equal to 0. Okay? Take whatever is under the radical greater than or equal to 0. So here we said, well, we have to take x squared plus 5x minus 14 and say that has to be greater than or equal to 0. Right? Well, how would I solve something like this? No ideas? So yeah, the first thing we want to do is x factor, right? We want to solve this quadratic. So I want two numbers that multiply to negative 14 that add to positive 5. Seven and negative 2. So this would factor into x plus 7. X minus 2. Okay. So solving this then, we would get x equals negative 7 and x equals positive 2. Whenever we have an inequality, what does that mean? Okay, this is one thing that usually ends up tripping students up. Okay? I mean, I know you did this in pre-calc. I'm pretty sure you did this in algebra 2. What do I do with those numbers now? That's a good thought. Okay, saying that the negative 7 wouldn't work because it's not greater than 0. But it's actually a little bit different process when we're talking about a quadratic, saying that has to be greater than or equal to 0. Does anybody remember what we need to do? Okay, we'll take a look at a bit. Well, maybe that would help if we did that first. Plug them in? What do you mean by that?
Plug it in and solve it and see if the equation you solve is greater than or equal to 0.
Plug these numbers in?
Yeah.
Not quite. You're on the right track. We're going to plug something in. So, here, let's x squared plus 5x minus 14. All right, so this is a picture of that parabola. Okay, so we found our zeros, right? Our zeros are at -7 and +2. So visually what we're saying is, where is this parabola greater than or equal to 0? Well, hopefully visually we can see it's here and here, right? Okay. The y values are positive on these two parts of the parabola and negative here. So in practice, if we don't have a picture, what we do with these two values, we put them on a sign chart. And then we test a number less than -7, a number in between -7 and 2, and a number greater than 2. Okay. Is that ringing bells? No? You guys didn't do this in pre-calc?
I don't remember it. I like to do it. I don't know how to.
Alright, well, I guess if we don't remember this process, I think we'll actually do this process a little bit later on. So maybe we can just worry about dealing with linear functions now instead of quadratics. So I guess if we don't remember that process, don't worry about this one here. Okay, we'll come back to solving quadratic inequalities later. Okay, but the idea, okay, is to take whatever's under the radical and say that has to be greater than or equal to 0. That's the important idea for this section. So let's jump back over to D here. Okay, this one actually combines both of these possibilities, right? We have a denominator and we have a radical. So that radical is in the denominator. Well, this tells me to set the denominator equal to 0, but then also say it has to be greater than or equal to 0. Right? So if we can't have 0 in the denominator, and I want anything under the radical to be greater than or equal to 0, what could I do here instead of doing two separate things? Right? If I want the denominator to be greater than or equal to 0, but not equal to 0, I just want whatever's under that radical to be greater than 0, not greater than or equal to 0. So we can't have zeros in the denominator. Right? So I want whatever's under that radical to be greater than 0. Hopefully this one's an easy one to solve, right? We would just add 8 over. Yet that x has to be greater than 8. I want this in interval notation, though. How do I turn x is greater than 8 into interval notation for my domain? What does that mean? 8 to infinity, right? This means that every x value, starting at 8 and going to infinity, will work. Do I include 8? No, right? Because 8 would make the denominator 0. That was the point of not including 8 here. So my interval notation for my domain here is 8 to infinity.
I was wondering, can you just make it a 9?
That's a good question. Can you just make it a 9? Would that work? Could I say x has to be greater than or equal to 9? Why not? Yeah, right? We're not just talking about whole numbers, right? So what about 8.5? 8.2? Right? So yeah, we say we're starting at 8, just not including 8, because 8.000001 will still work. Right? We okay with that one? Okay, so let's take a look at E then. Okay, again on E, both of these scenarios crop up. Okay, we have a denominator and we have a radical. Okay, this time the radical is not in the denominator, so we will have to deal with those two things separately. So I want to say, well, I can't let this denominator equal 0. Right, so I'll say x minus 4 not equal 0. Add the 4 over, and we get that x cannot be 4. Okay. Then separately, we have to deal with this radical. So I want to say whatever's underneath that radical has to be greater than or equal to 0. Okay. Well, I can just add the x over. Okay. Get that 1 is greater than or equal to x, or in other words, x is less than or equal to 1. So I've got two different things going on here. Right? I'll rewrite it like this. So the x is first. So I know x has to be less than or equal to 1, and x cannot be 4. How do I deal with this? Right, we just wouldn't include 4. Does that matter then? This one's actually kind of a trick question. X has to be less than or equal to 1. So 4 doesn't even matter, right? We already know that x has to be less than or equal to 1. This piece doesn't even matter. A lot of times this will matter, though. A lot of times this would be part of this piece, and we would just have to create a hole like we did up here for these examples, right? So this actually doesn't give me any information for this problem. How would I write this in interval notation? Negative infinity to 1. Okay, so when we're looking at domain from equations, two things that we need to take into account. We can't have zeros in the denominator. We can't have negatives under a radical. Questions on that? Oh, yeah, you're right. Oh. One should have a bracket.
We would be right. The one four, right?
Yeah, this one would be a parenthesis because we can't have 8 because that would give us a 0 in the denominator. All right. Any other questions on finding domain from an equation? All right, then let's look at domain and range from a graph. Okay, domain is just all of the x values that the graph reaches, right? And range is all of the y values. So, on this graph, bless you, what are all of the x values that this line segment reaches? -3 to 2, right? Am I including those endpoints or not? Yeah, right? They're solid dots on the graph, so I would be including those. So my domain here is -3 to 2. What about the range?
All right, I guess it would be -4.
Right.
That makes more sense.
Yeah, always start with the smallest value, right? Whenever we're describing something in interval notation. So the smallest y value I reach is -3. The largest is +4. Okay with that one? All right, the second one, we've got some holes in this graph. So how would I describe the domain, all of the x values that we reach? What's the smallest x value that I get to? -3, is that included? No. -3 to 1, is 1 included?
Yep.
Yes. And then I've got a break, and a jump in the graph. I pick back up at 3. So I'll union this. Is 3 included? Nope. And then where do I end? +3. infinity included? No, you can't include infinity. It's not a number, it's an idea. So the domain is -3 to 1, and then 3 to infinity. How about the range? What's the smallest y value I reach? -1 included, up to +3 included. Sure. Then what? Then I've got a jump, right? So I'll union that. And then 4, is that included? Up to positive infinity. Now what? Why doesn't this piece factor into the range here? Right? I mean, the y values stop over here, but that's not accounted for anywhere in my range.
It's still on there. Different x value.
Right. Okay, that y value is accounted for over here. Right? Questions on anything with domain and range? All right.